Alright, this is going to be an overview of the Motorola 6809 trunking controller. First things first, if you're not already familiar with how trunked radio systems work and that concept, I would suggest just doing a little bit of research to get a basic understanding of them first, and then everything that I go over in this video will make a lot more sense. So I'm not going to go over like basic concept of trunked radio, I'm just going to be demonstrating this controller and showing its hardware and its features and everything. So, this is called a 6809 controller because it uses a Motorola 6809 microprocessor. It's based heavily on that and has several of them within its chassis. This is the smaller SmartWorks version of the system. There are a few different variants. The full-size original chassis and arrangement is called SmartNet, and those chassis can be linked together and form a full-size system. The SmartWorks chassis, which is this one, is meant to be a smaller installation but include every single feature in one chassis. So this has everything that it needs to be a fully functional system just within this one chassis. There's no necessary, you don't have to link multiple chassis together or anything. So it's basic system, it can have a console interface, and it can have a telephone interconnect, all just within this one. Now, this hardware platform with the 6809 processors was the original one that handled the very first Type 1 Privacy Plus trunk systems all the way up and through Smart Zone. So they just upgraded the firmware in it over time and made new cards for it. So this one has pretty new firmware on it and it supports all the fun stuff. Like I can affiliate this system to a Smart Zone controller, like an MZC3000 or some form of zone controller, if I wanted to, but I don't have one, so this is just running standalone as one singular trunking site. Now I mentioned it's a smaller system, so this is limited to 7 channels only. That's voice and control combined. So the larger SmartNet chassis, you could have multiple transmitter and receiver interface cards in one chassis. This one you can just have one. So one card with 7 channels total. And these were originally intended to connect to the Motorola MSF5000 and Quantro/Quantar repeaters. I don't have those because they're expensive and they're large. I would love to have them, but getting them in any usable band is very difficult, at least financially. So I've resorted to making my own interface up here. So these 2 breadboards, this is not the final state of this by any means, and I'm going to completely redo this circuit. There's a few different problems with it. Eventually I'll just have a little PCB that you can plug into one of the DB15 connectors, and it'll just have screw terminals to interface with a regular radio. But for now, this is my custom interface circuit. Just ignore that, that's not standard or anything. I have this interface to these 4 radios down here. So these 2 are used for the control channel, these 2 are used for the voice channel. The top 2 are CDM 1250s. These are the low power ones that you can turn all the way down to 1 watt for transmit. And because of that, they're set for 1 watt transmit, and unlike the GM300s and Radius and MaxTrack radios that are very similar, I can have this CDM that's on the control channel transmit for hours upon end continuously without any overheating problems, which is very nice and makes this a lot easier to test. So those are the transmit radios. Below them are 2 Radius GM300s. These are just being used for the receive side of the control channel and the voice channel. So channel 1 is currently not in use on this controller. I intended to fix it before making this video, but there's a problem with one of the optocouplers on the receiver interface board. So that needs to be fixed before channel 1 will function properly. So channel 2 and channel 3 are these radios and these radios respectively. Channel 2 is the control channel, channel 3 is the voice channel. So only one voice channel for this demonstration. Now, I guess I'll go over the hardware. I guess I'll just go through all the different cards first, and then I'll explain the different ports up here. And the one other thing I was going to go over in this video was the command line interface for programming this controller. Now, I'm not actually going to go over that in this video specifically, because I just ended up finding another manual for this controller that lists some of the information that I did not have yet for the command line interface. So I'm going to wait until I have that before I do an overview of how to program it. And I also do not have the telephone interconnect working. That's what these 4 cards are for. So these I'm not going to go over in this video, just know that those are related to the telephone interconnect. I need to get a power supply that's capable of more current, first and foremost, but then I also need to do some changes to the backplane on this controller before I can use these cards. So that will also be a separate video. So, hardware-wise, I'm going to start with the CSC card. This is the central site controller, or just the main controller for this entire system. So this card holds the database of all the different radios that are authorized and the timing parameters and the system configuration and all the information about this trunking site. That's all stored in the CSC. Now, every card that says site controller on it, like this one does, and the RSC and the TCI and the MCB and the TSC is what that is, every single one of them that says site controller contains a 6809 microprocessor and RAM and EEPROM and everything else needed to get one running. So, as you note, these labels are kind of falling off. I'm going to completely make custom labels at some point. I just haven't gotten to it. I've had to re-glue a bunch of these multiple times. They just keep falling off. So I'm just going to completely redo them with custom labels at some point. But I will mention what these are. So obviously this one should be ACB1 right below that. Anyways, CSC card, main controller for the system. Every single card that has a 6809 processor in it has the same arrangement of buttons and lights on the front. So first off, we have a disable button. This does not seem to do anything. I believe it's just read by software, and in this case, the software running in the system does not make use of this button, at least not in the SmartWorks variant. So the run LED is lit whenever the processor is running normally. So if there's ever a brownout reset or a watchdog reset, this light will go out either momentarily for a watchdog reset or until the brownout condition restores for a brownout reset. There is also a disabled LED. This will turn on whenever the processor is being reset, and also it'll turn on if the processor is disabling if this card is disabling its own functionality based on some software condition. So for example, the RSC card that's right next to it, this one has to communicate to this one first before it can even operate. So until this one's fully booted, the disabled LED is turned on through software on the RSC. There's a reset button here. This does exactly what you think. It just resets the processor and all the other logic chips on it. So if I press that, it'll reset this card. There's a test button here. So whenever you first power up one of these cards, it runs through a self-test operation. So it'll test all its RAM and verify checksums and all that. You can also start the test manually by pressing the test button. Whenever the test is active, the active LED will light. And whenever there's a failure in the self-test or any other alarm condition on this particular card, it will light its red failure light. There's an indicator test button on all these cards, so if I press that, it just lights all the LEDs. There's an alarm cutoff switch, which this is one of the ones that can go in and back out. And it's not happy about something. I'll have to check the diagnostic messages. It could be... Oh, that's why. By pressing the indicator test, it drew more current, and the TSC card just reset itself. So I'll clear that alarm in a minute. Anyway, the alarm cutoff switch, if there's an alarm condition, like there very conveniently now is on this card, it activates a relay, which you can wire to whatever alarm system you want monitoring this. Whenever you're working on it and you want to suppress that from happening, you can enable the alarm cutoff, and that will prevent any alarm condition on this card from activating your relay and causing your alarm system to go off. So that's independent per card. Whenever there's at least one card that is not in alarm cutoff mode that has an alarm condition present, the relay will activate. At the very bottom, there's a key switch here. It has two positions, either run or service enable. Now, when it's in the run position like it is right now, I guess you could say more critical buttons like the reset button and the test button and the disable button, those do not have any effect when it's in the run position. So if I press reset, nothing happens. However, if I were to put this key switch in the service enable position, then this card will register the reset button being pressed and actually reset the processor. And that is the same thing for any of these other cards that have buttons that can go in and out, like this channel 3. I can disable it by pressing this button. It doesn't actually take effect until you turn the key switch on the associated controller that that card belongs to. So, and that is latched. So if I disable this and turn the key switch back to run, it'll keep that state. So if someone were to put it back to enabled, it won't change until I first put the key switch into service enable again. And that's the same across any card that has a processor on it. They all work about the same. So anyway, that's the central site controller card. Next, we have the RSC card. This handles anything that has to do with the receiving portion of the radios and decoding inbound control channel messages from subscribers on the system. So interfacing, this card interfaces with the next two cards, the IRB and RIB card. It'll handle anything that has to do with receiving operations. And the RSC communicates with the CSC through an internal 4800 baud RS-232 bus. So the RSC does not have any parallel memory access to the CSC. They just communicate messages to each other over a 4800 baud serial bus. The inbound recovery board, the IRB, is controlled by the RSC. This board decodes inbound 3600 baud control channel messages that are being received on the receiving side of the control channel. So whenever you're sending an inbound control channel message, this card is responsible for decoding that square wave serial stream and writing it into memory and verifying that it's correct. So that's what this card does. That is the sole purpose of this one. It also has LEDs that indicate which channel is currently the control channel. Only channels 1 through 4 can be control channels on this arrangement, so control channel 2 directly correlates to channel 2. The decode LED flashes whenever it's decoding a message. The unsquelched LED is solid whenever it's receiving audio from the receiving radio for the control channel. So the audio coming out of this is not squelched. It's just continuous static at the moment coming into this controller. It has its own squelch that this card handles for when it's decoding, when it's in data mode and it's decoding control channel messages. Whenever the IRB card is not initialized properly, the failure LED will be on. Next, we have the RIB card. This is a receiver interface board, as it says, receiver interface right here. So this just has a bunch of opto isolators and audio circuitry that just interfaces with all the receiving radios. So the channel 1 section here is the same for channels 1 through 7 here. There's a receive LED above each one. That lights whenever the carrier detect signal from the receiving radio is active. So even though this is unsquelched audio coming from this radio, it also provides the carrier detect signal to the controller. So it does not interpret an inbound control channel message if the carrier detect is not active. So if this decode light were to flash right now like it's trying to decode a message, the CSC is going to ignore it because, well, the RSC is going to ignore it and not even pass it to the CSC because it's not even seeing carrier on that channel from the receiver. But anyway, the receive light lights whenever it's receiving something, and disabled lights whenever that channel is disabled, either through the switch on the front of the card or in software. Next up, it doesn't have a label on it, but this is the TSC card. It's basically the opposite of the RSC. This is a transmit site controller, so it does everything that has to do with the transmitting radios and encoding outbound 3600 baud control channel messages and generating the subaudible signaling. Well, I mean, the transmitter interface board itself generates the subaudible signaling, but the TSC is involved in all of the transmit operations. And the next card is the TIB. It's basically the opposite of the RIB. It's very similar. The buttons and the disabled LED work the exact same, and instead of a receive light, it has a transmit light. So whenever the transmit light is lit, this card is telling that channel to transmit. Now, this radio is off right now, so it's not actually transmitting, but the push-to-talk signal coming out of this card for channel 2 is active, and if I turn this radio on, it will begin transmitting. And the TSC does communicate with the CSC as well, this one, through another internal 4800 baud serial bus. So the bus between the CSC and the RSC and the CSC and the TSC are separate. They're their own 4800 baud buses. They do not share one data bus. Now, on the left here, I've got two other cards. We have the TCI and ACB1 card. The TCI is a trunked console interface. So this system can be connected to a Motorola Centricom console, which I do not own one of those. I wish I did. I would also have to get the appropriate CEB, Centricom Electronics Bank, cards and equipment to interface with this controller. So I would love to demonstrate that someday, but I do not own that equipment, so it's actually not in use. Now, the ACB card here, I can pull the other one out and show you. These actually just contain a whole bunch of UART chips. So these are the Motorola ACIA chips that are UARTs designed specifically for the 6809. And it has 5 of them on this board. It's just alongside the appropriate line drivers and everything that's back there. So this is literally just, it sits on the parallel bus that a processor can address and has 5 individual RS-232 interfaces. So the ACB1 on the left here is controlled by the TCI card. So it uses the first 2 serial ports on this card for interfacing with a Centricom console. It sends data signals over the serial ports, and then the voice would be controlled over, would be carried over leased line, or sometimes microwave or T1. Depends on how your system was connected. But the TCI has everything to do with the Centricom console. It is inserted in this chassis because the RSC's internal 4800 baud serial bus, the transmit side that the RSC is generating, first goes through the TCI before it goes into the CSC. And that is actually controlled, I believe, by these dip switches on the backplane here. So these are ribbon cables that connect this top portion I'm going to go over in a second to the rest of the chassis. And you might be able to see them. There's some dip switches in there. I have no documentation on those, and it's a really big pain to trace the traces on that backplane. So I'm going to figure it out eventually, but for now, these two cards are not in use. They're just inserted to keep the system happy, because if this card is not present, the actual transmit line coming out of the RSC does not reach the CSC. So that's why those are there. And in terms of these serial cards, they have a ready LED that indicates that this port is active and working. They have an error LED which flashes whenever it's a software error problem, or they are solid. So software error being this error LED will flash whenever this channel is not disabled, and whatever protocol is being ran over that serial bus by the processor that addresses it, so the TCI in this case, is not working properly. So if this is enabled and hardware-wise it's working correctly, but it cannot see the Centricom console on the other side, this error LED will flash. However, if this card itself, the ACB card, is not being addressed properly or is not initialized, the error LED will be solid on, and the disabled light lights whenever this channel is disabled. The second ACB1 card, I believe, has to do with the phone interconnect, so I'm not even going to mention it for now because I'm not certain on what all interfaces with it. So that is all the different cards that are currently in operation. Again, I'm not going to go over the various cards for the telephone interconnect until I get that working and fully understand it. So up here, this board is just all the external interfaces. Across the top are a whole bunch of male DB25 connectors, which are RS-232 ports. They have a standard pinout, and they only use the A side, like the first of two receive and transmit pairs and all the flow control lines for that. So they're DB25, but they only have one port per physical port, I guess you could say. So on these, going from left to right, the first one is the what's called the System Manager Terminal, SMT, serial connection. So that's the RS-232 port that you manage the system through. It's typically connected through to either a teletype in the very first instances of this system. All the old service manuals show it being connected to an actual physical TTY, but later on, just a regular serial terminal will work fine with this. There's also a software package that I'm forgetting the exact name of. However, I have not been able to find this yet. There's a software package that also will communicate with this controller over that same terminal serial port, and it lets you back up the system configuration. Now, I really wish I had that because all the cards that are site controllers have spots for lithium batteries that are rechargeable, and all the batteries in this thing were completely leaking and horrible when I got it. Luckily, it didn't damage the board too much. I've been able to clean up any of the traces and everything around it, but I just removed those lithium batteries, so if I power off this system right now, it completely loses all of its configuration, which is quite annoying. I'm going to try to put a supercapacitor in there along with some circuitry to let it charge it properly, but until then, if I power this off, I lose all the configuration. And I'm getting sidetracked. I was talking about serial ports. So yeah, the first one is the terminal interface that you manage it through. I will show that command line in a later video. The next one over is labeled CSC_RSC. That is the internal serial bus between the CSC and the RSC. So if you connect a little serial monitor, which I probably have one. Nope, it's not over here. Well, I was going to show you, but if you plug one of those little adapters in there that have the little LEDs for each of the serial signals, you'll see that both the transmit and receive lines are being provided on that port. So you can't just plug a regular serial cable into that port. It monitors both the transmit and receive side of that bus. So the second port is the bus between the CSC and the RSC. The next one is labeled CSC_TSC. That's the same thing, except it's the internal bus between the CSC and the TSC. The next one over is labeled CSC_ACB1, and then ACB2, and then ACB3. Now, typically that would associate to channels on an ACB card. I have not, if I insert this ACB1 card with the system powered off and then powered back on, it never is initialized by the CSC. So I'm not sure if there's some setting I have to change, but my only guess for what those ports could be used for is additional management connections. However, I'm not certain of that because I can only ever find references to one singular serial port, the one on the far left, being used to manage this controller at a time. So no, you could not have two consecutive terminal sessions into it. It was only one. But if I had to take a guess, those 3 additional ports would be on this ACB card and potentially communicate with the CSC for additional simultaneous terminal sessions, but I've not gotten that to work yet. If I get any further information on that, I will make an update in my next video on this. Then on the right, we have 4 more serial ports. The first ones are labeled TCI_ACB1 and TCI_ACB2. Those correspond to channels 1 and 2 of this ACB card, and they are the RS-232 data channels that the TCI uses to communicate with the Centricom console. So that's what those are. And then the last 2 are MCB_term and MCB_backup. Those have to do with this card here, which again, I'm not going to get into these yet because I don't even fully understand them yet. And I've not been able to power them or verify anything, so I'm not even going to mention what those serial ports possibly do. Now, in terms of other interfaces up here, try not to block the bad lighting too badly. We have a massive RJ21 connector here, and this is used for the telephone interconnect. I don't know what the pinout of that is yet. And then we have this 4-position terminal block that has major alarm and minor alarm contacts. So this does have the concept of major versus minor alarm conditions, and the major alarm contact is the one that's activated whenever one of these failure lights is lit. So there are 2 read relays on not this board, but the backplane of this chassis that drive those contacts. The bottom one here, that's a larger connector, screw terminals, I don't have any information on that one yet. If I had to take a guess, it would have something to do with the Centricom console interconnect, potentially audio to and from this controller, but I don't have a pinout for it, and I haven't traced it yet, so I'm not sure on that one at the moment. And then the only other interfaces on these are all these DB15 connectors, and all of those are for all the different channels. If you were to look at a full-size SmartNet chassis instead of this one, which is SmartWorks, this top bit is larger and it has a whole bunch more serial and DB15 connectors on it to accommodate the additional cards. So that's a pretty good way to tell whether it's a SmartWorks system or a SmartNet system that you're looking at. Of course, the firmware is different as well, but if you see one that has more than one row of DB15 connectors, that's a larger chassis. So each DB15 has the transmit and receive interface like lines, so audio and signaling and everything for one channel. So the first DB15 on the far left here is for channel 1, the next one's for channel 2, the next for channel 3. As you can see, I only have 2 and 3 connected, those going to my 2 breadboards here. Okay, that is all of the hardware on this. Now, I guess what I will do is go ahead and demonstrate some radios with this thing. So, first of all, I am running this in ham frequencies. I don't know if I mentioned that yet or not, but, sorry, changing hands here. It's gonna be horrible. I'm running this in ham frequencies, of course not continuously. I picked 4 frequencies, receive and transmit for 2 channels that are not in use here at the moment, and I verified nobody else is on them, and it's 1 watt anyways. So, because it's ham frequencies, I need to ID on all 4 of these by myself, at least every 10 minutes. So I'm going to ID on them now, then I'll turn on this control channel radio so that we can start getting a control channel, and then I'm going to go demonstrate how the radios work and some of the features of the system. So I'm going to use this Apex 6000 as I always have been to just ID on all 4 channels real quick. KJ7BZC. 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 And one more. KJ7BZC. Alright, So you saw the receive lights flash whenever I hit the control channel input and the voice channel input. So now I need to put this back on the control channel output. Oh, and actually, let me let you listen to this. Well, you heard a second of it. This controller is capable of sending Morse code ID. However, it only sends it on one of the channels, and it only sends it every 30 minutes. So that does not comply with ham specifications. I cannot change the interval or the behavior of that. So it will do that, and that is the proper IDing protocol for commercial systems, but for ham, doesn't cut it. In the past, I did make a little program for a PIC. What was it? Model doesn't matter. But it was a little 8-pin PIC microcontroller that just sends CWID on each channel for me. I'm going to set that up on my final interface board, but for now, just manual IDing is all I can do. Now, I'm going to turn on this radio, and we're going to see if it's going to play nice. Nope, it is not going to play nice. So, these CDMs have weird behavior sometimes when you turn them on and they immediately start transmitting. I don't know what it is, but I just need to disable and enable channel 2. And whenever it's not in a trunking state, so there's no control channels, it's in fail-soft mode right now, it keys up every single channel. So once this goes back into a trunking state, which takes quite a while for some reason, hopefully we'll be okay. And now we wait. Come on. I was hoping this wouldn't be a problem this time. Okay, there we go. Yeah, so something is up with, I don't know if it's just this specific CDM, but it does not like it when I turn it on and it has to immediately start transmitting. So sometimes the audio is messed up and I can literally hear it in the control channel. So now let me move this to the proper channel and we're affiliated. Okay, so let's go demonstrate this with a few radios. I'm going to head out here. Of course, the furnace has to be running. And come over to these 3 radios. So here we have the Apex that I just brought over here and 2 XTSs. All 3 of these are configured for this Type 2 trunking system. It's all in VHF range, of course. Let me clear the system alarm real quick. Okay, so that's the terminal interface. I'll show it in detail in the future. So I guess first things first, let me just go over these radios and turn them on and let them affiliate. So if I turn this on, there, affiliated. So these are all, of course, configured for Type 2 only. I don't even think these radios can do Type 1 operation, so I've just configured the system for Type 2 mode only, just for simplicity. Now, the radio IDs, it's a little bit weird and I don't fully understand this yet, so I'm hoping some of the other manual that I got for this, whenever it arrives, is going to clear this information up a little bit. But when you're working with radio IDs from radios themselves or from the terminal interface, they show up as 7 plus 5 digits, so 7000001 through 765534. 65535 is not possible. I don't know why. I can't add it and I can't address it from radios. It's probably reserved for some reason. Same with all zeros. So whenever I'm entering IDs on these, if I do 700001 in this radio, that's this radio's ID, and in the CPS, it's programmed for ID number 1. So even though I'm entering a 7 and entering it as a 6-digit number, 700001 is this one. This one's 700002. This one is 700003. So that's the radio ID situation. Now, of course, first things first, we could just key up on this talk group. We get a talk permit tone. And on the other radios, it shows this one's ID. If I turn up the volume on this one and talk through it, you can hear me. And then I don't know if it's super audible, especially with the furnace running, which I hope it'll stop in a moment. But whenever I stop transmitting, if you listen closely, you can actually hear the low speed data signal that the controller is superimposing over the voice channel. If you hear that, just know that is not normal. That has to do with my audio interface not being ideal, which I will fix that in the future. Just for now, it's audible and it needs its level adjusted. So yeah, basic transmission, I can key up on any of these and they will talk to each other just like they should on a trunk system. That's the least interesting bit. Now, actually, let me just leave this off because you can see it a lot better with the backlight in this dim mode. Next, I can just do a call alert. So yeah, let me send a page from 700001 to 700002, which is this one. And as you can see, page received from 700001. So that works exactly how you would expect. This one transmits a call alert message. Actually, it works a little bit different than you would expect. This radio sends a message to the controller saying, send a call alert to this radio. The controller first verifies that that radio ID is valid and in the database. So if I try to do a page to like 7111111, no, that's the right number of digits. It'll immediately tell me that's an invalid ID. So 700000, it'll say invalid entry. But if it is a valid ID, like 700005, but it's not in the database, it'll check with the controller first, and the controller will immediately tell it, hey, that's an invalid ID. Contrary to if I turn this radio off, this one's 3, remember, and I say 700003 and try to page it, now the controller lets me try that, and this repeatedly transmits it, but now we get no acknowledge. So it's a little bit different than conventional operation, as in the controller can verify that a radio ID is indeed valid first. So that's call alerts. And of course this can go either way. So I can page 700001 from this one. And it works exactly as you would expect. Now, the one other thing I can easily demonstrate at the moment is private calls. So these are all on talk group 1. If I had another talk group in the system, I just really didn't feel like programming all these 3 radios again. It works just like changing the channel on a conventional radio. If these 2 are on talk group 1 and this one's on talk group 2, this one will not hear these and these will not hear this one. So just basic talk group operation. Now, private calls, these are all 3 on talk group number 1. However, say that radio ID 1 wants to talk privately with radio ID 2. Not encrypted, but just a direct conversation between these 2. We can initiate a private call. So call, instead of being selective call, is now private call. I'll do call, and I'll do 700002. I'm gonna turn the backlight on. And if I do this one generates a ringback signal. And this one repeatedly says call received. If you go into call and transmit, that accepts it. And now what you'll notice is we're in a private call mode. And if I transmit on this one, this XTS2500, which is not a part of this private call, does not receive any traffic. If we just exit on both of these, now this one hears us. So a private call is just private communication within the same talk group. Well, not even within the same talk group, it's completely separate. But this radio and this radio, when they're in a private call, can only hear each other. Well, they'll only talk to each other. Any other radios will not be a part of that. Now, let's just establish a private call between these 2. Not page. It's the other order on this one. The ringback signal is the same on the XTSs. Except they say, please wait. I'll accept this. So this one is not seeing our transmissions at all. It's easier to see with the display. But this one is acting as if there's no traffic on the system because in its perspective, there is no communication happening here. Now, while these are in a private call, which let me just key that to make sure that it's not going to exit on its own. If I try to send a page to, no, not status, say 700002, These radios will not actually hear a call alert coming from another radio if they're in a private call. I'm not sure if that's intentional or not, but that is how it behaves. I think that is just about it, except for emergency, which I just realized I forgot to change one of the parameters for that. Let me just do that real quick. Very slowly type with one hand. We want... Oh. Okay. So I have changed one parameter in the system, which of course resets itself every time I power cycle it. Now, emergency operation on conventional systems, typically you have a console radio, and when you push your emergency button, your radio transmits an emergency message, and the console will send an acknowledgement back to you, and then your radio says acknowledge. In this case, the controller itself acts as the console. So if I activate an emergency transmission from one of these radios, the controller itself is the one that will acknowledge it. So let's do an emergency from the XTS 2500. So this one acknowledged, and now it's in emergency mode. We see emergency alarm received. If I key up on this radio now, we see emergency call from this one. And now you'll notice, I don't know if you can hear it, it's actually kind of a good thing that that's audible. This voice channel is now dedicated to us for the set duration. So I set it for 10 seconds, so it actually just stopped now. But whenever you're in emergency mode, and I need to reset this one. So that's exiting emergency. Whenever you're in an emergency mode, you can set the controller to find an available channel and dedicate it to you for a certain duration. I have it set for 10 seconds. So even if other users were trying to use the system at the time, because you have emergency traffic, you're dedicated that voice channel specifically for the set amount of time. And I don't know if you saw it, but when I cleared emergency mode, it did send a message to the controller saying, hey, I'm no longer in emergency. So if I transmit now, it's just a regular push-to-talk ID, not with EM : in front of it. And that is about it for radio features. What I will show is disabling a radio. So let's just remove my Apex from the system's database. Now, let me go off this channel, control channel. We can still affiliate to the system, and it'll successfully affiliate. However, this radio is not in the controller's database. So if I try to do a page to my Apex, which was previously 700001, the controller now says, hey, that's invalid. I don't know what that ID is. And if I try to transmit on this radio, it just immediately is denied. Because the controller itself, this radio checks in with it and says, hey, I'm ID this. The controller says, you're not allowed to transmit. I don't know who you are. And same with anything really. Like if I try to go into emergency mode on this, it immediately just says denied. It still stays in emergency mode. However, the transmission itself is denied. And let me turn off you. Okay. So that's what it looks like if a radio is not on the system. It can still affiliate, and it can still sit on the talk group. So if I transmit on this radio still receives it, even though it's technically not in the database. Which is interesting, but I believe that that's just a limitation with how this system works. There's no way that the controller can restrict this radio from hearing the outbound status word on the control channel that says where the conversation is. So I guess it makes sense that it can still receive, but it's a little bit confusing. Now if we add that one back, and we try to transmit again, now we're back to normal. So that is the various operations on these radios and the Type 2 trunking controller. Of course, this is just scratching the surface of what these kind of systems can do. I cannot demonstrate the phone interconnect, and if you try to go into the phone interconnect, like just dial any number, just immediately denied because the controller is actually not aware that it even has those cards. They're not inserted and they're not programmed in. So eventually I will make a video going over the telephone interconnect once I get that working. I will make a video going over the rest of the terminal interface and how to configure it. once I get the other manual and get some more information on it. And that's actually probably a good thing because this video is already 40 minutes long. So in that case, that is my Motorola 6809 Type 2 trunking controller, and it is now fully operational. So yeah.